Hello everyone, welcome to our webinar today. So the title of our webinar is Composite Structures Made Simple with Advanced Design. So today we will talk about how to model composite beam, which is a new feature in Advanced Design. We will go through some modeling and results. My name is Farshad Purshad and I am the Senior Technical Manager for Graitec Simulate products in US and Canada. So let's go on with our slides. So our agenda today for this webinar, we will start with an introduction to composite beams. We will cover the modeling and user interface in advanced design. We will see how we can get our results. Then we will have a demonstration inside advanced design, inside the software, about this feature, and finally we will have a questions and answer session. So while I am presenting, please feel free. If you have any questions, you can just type them in the platform's chat tool, and I will be answering the questions at the end. Okay, composite beams, as you see here, they are being used and they can be used in some buildings and structures. So basically we can benefit the composite action of concrete and steel in these type of elements. So the design code that we have in advanced design for composite beams, currently we have it based on AISC 360 codes, and it is in plans to develop it for Canadian codes as well. By the way, we also have it for Eurocodes. So the way it works, basically you define your steel beams under the concrete deck or slab. So we have the option to define either a concrete composite deck, which means steel and concrete, like the image that you see here, or you can also define a uniform flat slab to work with your composite beam. We have the tools to define your studs or shear connectors, and advanced design will be able to calculate the resistances and give you the spacing and etc. And as well, we will have dedicated properties for verification and calculations, like such as properties like effective width, construction stages, and etc. So as you see here, when you start advanced design, you can select the composite design from here, and then you can select the code that you want to perform the design based on that. So how the modeling will start? First of all, we will start with defining the steel element, and we have now a new usage type in beam properties, as you see here, which is called composite beam. So the first stage will be just switching your usage type to composite beam. And after that, you can just move on with defining the other properties of this steel beam, like material and sections and other properties that we normally use for steel structures. In the second step, we will define our floor deck or slab with its properties, which is here. So I have a screenshot there. And as you see now, we have a deck type, which you can assign a composite deck, or this can be also switched to be a flat slab. And then you can define the properties regarding the slab, which will work in your composite action. Then after designing or defining these properties, you can go on with creating your 3D model. So here I have a screenshot of a simple model that I have here. So these beams that you see here, they are all composite beams. The next step is going to be drawing your deck slab. So it is going to be like in you have in advanced design, it's going to be a planar element, but with properties defined to work as a composite action with a steel beam. And finally, what we have here at the bottom of the steel member properties, you will have your composite beam design like you see here, and there you have properties to define specific properties of composite action. For example, the effective width, the studs, the lateral support condition, and other design properties related to steel composite beams. So, and as you see here, we will have a composite design tool that I'm going to cover shortly to define all of the settings. So the types of the deck that we can use for this composite action, you can actually use two types. So it can be a steel composite deck, as you see here. And also we can use a uniform flat slab to define for our beam. And we have all of the properties regarding both of those elements. So as you see here, can define the deck properties and etc. And as well, you can also define your rebars inside the deck to cover the full behavior of concrete and reinforcement. So the properties of the deck will look like this, and you can just modify based on your design. So the floor deck that you will define, it will work with composite beams to transfer the loads. It can be defined, as I mentioned, as a uniform slab or composite deck. There is no vertical stiffness, but we will make sure that the loads are being transferred through your slab to the composite beams. So slab has two usages here. So the first one is working in composite action with your composite beam, and the other properties is distributing all of the forces, live or dead or other types of loads, to your composite beams. And as well, it's going to integrate reinforcement and steel sheathing options in case of a composite deck. So the next step will be design properties and verification. So if you are familiar with advanced design, you will find in the UI that now we have also another extra icons here, which is just for composite design. And as I mentioned, it's going to work for ASC 360 and EC, and Canadian codes are coming. What kind of checks we will do for this composite beams? It's going to be bearing capacity and design and code checks in both construction stage and final stage. So you will have two options to decide. Like as you see here, it can be just final stage. So we are assuming that beam will be short, it's going to be supported. Or you can also define construction stage as well. So advanced design will do both checks for your composite beam, either under construction stage or final stage. So when you go to the options here, like composite design, you will see the settings option here. And if you click the settings, that is the place that you can define all of those properties and stages. So other properties as well here can be modified either for North American codes or Eurocodes, and you can define specific parameters for your projects there. So when you define all of the properties, then you can click the new analysis and design icon here, or check mark in advanced design, which is in addition to our concrete, steel, and timber. And now we have the composite calculation, which you can activate it. And if you click OK, the analysis and design will be performed based on composite design. And finally, one comment here, we have also automatic definition or calculation of effective weight for the beams. So these are going to be automatically calculated using this icon, or user will also have an option to define them manually. So talking about the results, we will cover most of the results required for a composite beam design, and we will display them. So these are like some of the graphical results. So first of all, you will have like how it works for timber and steel and concrete structures. You can definitely have the finite element results. So as you see here, like moment diagram, etc. for each beam. And on top of that, we can have the code checks or resistance checks for all of the required bending or vertical or etc. And those are going to be displayed as workload ratios, as you see there. The other type of results that we have, or actually you can display them, is going to be your effective weight which is calculated automatically by Advanced Design. So you can display them as you see in this screenshot. And finally, it's going to be the calculation of shear connectors or studs, which again, it's going to be calculated based on the parameters that you've defined in your properties of the element. And as you see here, it's going to be displayed here, and you can also modify them if needed. So these are like types of graphical results that we are providing for our composite design. And on top of the graphical results, we have also shapesheet reports, shapesheet results, and a report calculation. So as you know, in Advanced Design, we have some brief design results in as shapesheets. So you see some screenshots there for the shapesheet. So it's going to just give you the code check reference and the resistances and just a brief format of the design. And if you want to see like very detailed report on the design and equations and parameters that are being used, you can always use the report generator tool of Advanced Design, which as you see here on the right side, I have put some specimens there for you to see. So it's going to include all of the required design values and codes and parameters, so you can check your element in detail. So that was a brief overview and introduction to how you can define your composite beams and what are the parameters, how you can perform analysis and design, and finally how you can get your results. And now I'm going to have a demonstration directly inside Advanced Design so we can check these features directly inside the software. So let's move on into Advanced Design. Okay, I opened Advanced Design and you see the interface, and I have already prepared a model, simple model for you to see how all of these features and composite action will work. So first of all, you create your model and as I mentioned, as you know, like here, even in our project browser, you can see the beams, columns, supports, and floor deck elements in this model. So the first step that we need to follow is creating our beams. So it's going to work like a steel beam, but if I select one of those beams and check the properties, you will see that the usage type, now it's defined as a composite beam. And as you remember, if it's a standard or general element, you just define general. But in this case, because we want to do composite beam, we select the composite beam type. Then the other parameters is going to be our material and as well the section that we can select from Advanced Design's libraries for both of them. So for example, if you want to access more material options, you can just click there and you can access our library to assign our material. Same here for our sections. You can always also access our sections. So in this case, we are using W section, and all of the sections, as you see here, are available for you to assign to your composite beam. Then there can be other parameters like releases and etc. And finally, at the end, we will have the composite beam design. And now you can have extra parameters to define directly related to composite design. So those can be effective width, and as I mentioned, it can be done automatically if you activate this check mark, or also if you remove it, Advanced Design will let you know, will let you to define these parameters and effective width manually. So then you will have the shear connectors, what kind of connector we are using, diameter, strengths, and etc. to assign for your composite action. So basically you create your steel element and you create your 3D model, and the next option will be creating the slab, deck slab, and you can use again Advanced Design deck slab tool from here, which is going to be used for our composite beam. And as you see, we have different options here. So for example, you can use just floor deck option, and you will have the capability to just draw the floor deck on your steel beams. So if I select the deck here, you will see that now we are using a floor deck, which is named floor deck, but more importantly, here in the deck type, you can define what kind of slab or deck you want to use for your composite action. In this example, I am using a composite deck, but it is possible that you can have only a flat slab or uniform slab without the composite steel sheeting under it. So if that's the scenario, you can simply select the uniform slab option. And similar to your beams, after you define the type, you can also modify all of the properties here, like the concrete material or rigid diaphragm behavior or even direction. So in this case, its direction is important because we want our loads to be distributed on the composite beams. And as you see here, I have a sign here, these arrows that you see, which is showing that my deck is aligned correctly and it's distributing the forces on the composite beams. So after creating your elements and slabs, the next option would be you can define also or check the parameters regarding the design and verification. So you can find them always here. You go to analysis, and now we have the composite design. And if you click on settings, now we have the settings regarding this member. So you can have your calculation sequence. So here you can use if you want to do only for final stage, or you want to do both stage, which is going to be pure steel and concrete weight without composite action. That's going to be the construction stage or first phase. And also you can select for the final stage. As well, you can define some reinforcements here and the verification types here for effective width, which can be done automatically. So if you want to also automatically calculate the effective width for each beam, you can click on this option here, effective width, and it's an advanced design will automatically calculate all of those. So this is the way that you create your elements. So in this case, I'm just using one floor, but it's very similar. You can just define these elements. It's working like the linear elements, regular linear elements in advanced design. The only condition is you need to define your deck slab and also use the composite action. Then you can apply your loads. As you see here, I am applying some loads here to my roof. And finally, you can create your load combination. So after following all of those steps, you are basically ready to perform the analysis and design, which for that, you can go simply to analysis. And here you will have the option to put the check mark there and do a full composite calculation. As well, if you have a structure or the full model, which also contains other types of elements, other materials like concrete, steel, or timber. Beside composite, of course, you can just put the check marks here. And advanced design is multi-material, so it's gonna design and co-check all of these elements in your project. So in this case, I'm just gonna do a composite calculation. So I have ran the analysis on this model before, so we can just open the analysis. You click OK. And now, as you see, advanced design will mesh everything. And the first type of analysis that we have is our FEM results. For example, we can check for our deformations. And as well, you can check for internal forces of linear elements, in this case, which are composite beams. For example, I can go and check for my bending moment diagrams. And as well, I can check also for my shear forces on these composite beams. So after finite element results, now we need to investigate our design or verification results, which are here. So for example, you can go with max work ratio, which is going to be for both construction stages, or you can go one by one, like just for construction stage. You can check for deflections, number of studs, and etc. So for example, let's try our max work ratio and for our strengths. And as you see here, it's going to provide me with the design load ratios for all of my composite beams, which maximum is 91% here. You can also check for deflection. So if you have defined deflection criteria for service conditions or ultimate conditions, also you can check the results from there. You can check for effective width, as I mentioned earlier. For example, you can just go with this. And as you see here, you can see the effective width calculated for each of these composite beams here, which are being shown graphically. And as I mentioned earlier, those can be also modified by the user. Then here we have the stats calculation. So here, for example, we can have number and rows and etc. So let's go with number. And here for each composite beam that I have, you see the number of studs which is needed to cover the shear transfer basically between slab and steel. And you will see the number of rows and number of studs which is needed for each beam here separately. So these were like our graphical results for this example here. And now let's say if we want to get more detailed results, for example, we want to check the equations, code check formulas, and parameters in detail. Very simple. You can just select the beam that you are interested. You just click there, and then we can go into the shape sheet from here. And now you will see all of the parameters. So first of all, it's going to be all of the design parameters defined for this beam. So the profile, the height, properties, deck properties, steel studs or connectors, etc. The deflection checks, which we have defined them from here for our serviceability load stage. So advanced design will check for those as well. What we have here, this is going to be for your construction stage. So it's going to be just pure steel with weight of the slab on that without the composite action. So these are the formulas that we are using to basically check for bending and shear, etc. And after that, we also have the final stage, which is going to have more all of the loads, live loads, dead loads, snow, and everything else with ultimate load combinations. And as well here, we have also the composite action. And also advanced design can do some detailing checks based on AIC codes on the composite beam that we are designing here. So as you see here, all of the detailing checks are passing for this example. So these are like some overall results that we see here. But if you want to see even more detailed results, you can always click on Edit Detail Report, which is going to bring up our detailed reports for advanced design. So I'm just going to click here. So as you see, it's the shape sheet, detailed shape sheet for linear element 57, which was a composite beam. You see all of the properties. But if we scroll down, you see that now we have more detailed formulas and parameters to see how basically advanced design is performing the code check for each of the parameters and design requirements based on ASC formulation. So these are like very detailed, and here also you have the detailing checks for this beam. Okay, so we covered also the reports. And one final note here, because we are also meshing our floor decks in advanced design, you can also access the stress and strain and forces results for your floor deck as well, which you can always go to your stresses. And now you can select the type that you want to see here. For example, if you want to see S1 and top, And let's go to isomap and click here. So it's going to bring up your stress distribution on this floor, which can be used for extra verifications to investigate the floor stresses. So let's go back to our slides. Okay. So thank you very much for your attention. So this was like a brief overview of how to use composite design in advanced design. As you saw, it was very simple, and it can be used for different types of composite beams with different types of decks and sections, etc. So if you have any questions, please type your questions in the chat tool, and I will be answering them. By the way, if you need more information on composite design in advanced design, or you want to try it yourself, we can definitely send you trial versions. You can just contact our support first line, which is these two emails here, so support.us@graitec.com or support.canada@graitec.com. Thank you very much for your time.